Why is inverse kinematics elegant for robot algorithms? Imagine trying to tell a robot to reach out and grab something without manually calculating every joint angle. That's where inverse kinematics comes into play. It's a way for robots to figure out how to move their joints to reach a specific point in space. Instead of starting with joint angles and working out where the end of the arm will be, inverse kinematics begins with the desired position and works backwards. This process makes robot programming much more natural and intuitive. The beauty of inverse kinematics is that it creates a direct link between what we want the robot to do and how it should move. Think of it like giving a GPS destination and letting the system figure out the best route. For robots, this means translating a goal in three-dimensional space into the exact angles each joint needs to move. This is especially useful in tasks like assembly lines or robotic surgery, where precision and speed are key. Another reason inverse kinematics is considered elegant is that it can handle multiple solutions. When a robot reaches for an object, there might be several ways to position its joints to get there. Algorithms can choose the best solution based on criteria like avoiding obstacles, saving energy, or staying within joint limits. This flexibility makes robots more adaptable and capable of complex movements. Inverse kinematics also supports advanced motion planning. Robots can follow smooth paths, pick up objects, or change posture seamlessly. For example, a robotic arm in a factory can move from one spot to another while avoiding collisions. The algorithms generate the joint movements needed to produce those precise motions, often using mathematical tools like Jacobian matrices that relate joint velocities to end effector speeds. There are two main ways to solve inverse kinematics. For simple robot structures, exact formulas can be derived analytically, making calculations quick and precise. For more complex robots, numerical methods are used to approximate solutions through iterative processes. This combination allows developers to choose the best approach for each robot's design. Finally, inverse kinematics simplifies robot programming. Without it, programmers would need to manually calculate joint angles for every position, which is time-consuming and prone to errors. With inverse kinematics, they can simply specify the target position and let the algorithm handle the rest. This makes developing and deploying robots much faster and more efficient. In the end, inverse kinematics is considered elegant because it transforms complex spatial goals into straightforward joint commands. It makes robots smarter, more flexible, and easier to control. Whether in manufacturing, healthcare, or research, this approach is a key part of writing effective robot algorithms and advancing robotic technology.